So welcome students. So in this question you're given that f is defined from r minus 0 to r, and the definition is f of x is equal to 1 by x minus 2 by 2 e power 2x minus 1. If this function has to be made continuous at x is equal to 0, what should we define f of 0 as? That's the question. So we know that for f of x to be continuous at x is equal to 0, limit x tends to 0, f of x should be same as f of 0. So if I have to define f of 0, I have to define it equal to limit x tends to 0 f of x, right? So what is limit x tends to 0? 1 by x minus 2 by e power 2x minus 1. That is equal to limit x tends to 0. So if I take the LCM, I get e power 2x minus 1 minus 2x by x times e power 2x minus 1. Now let me use expansions. So we know that e power 2x expansion is limit x tends to 0. E power 2x is 1 plus 2x by 1 factorial plus 2x whole square by 2 factorial plus so on up to infinity minus 1 minus 2x divided by x times, again e power 2x is 1 plus 2x by 1 factorial plus 2x whole square by 2 factorial plus so on minus 1. So in the numerator, as you can see, 1 and 1 gets cancelled. 2x by 1 factorial is 2x and minus 2x gets cancelled. And in the denominator, 1 and 1 gets cancelled. So what is left out? Limit x tends to 0. So in the numerator, so we know that as x tends to infinity, only the least power of x matters. So if you have a polynomial of x, only the least power matters. With respect to the least power, all the higher powers are negligible. So in the numerator, the term that is left out is 4x square by 2. It is 2x square plus so on. All the remaining terms are not required. With respect to 2x square, all the remaining terms can be neglected. Divided by, so in the denominator you have x, and within this, with respect to 2x, all the other things can be neglected. So x times 2x term is left out. So effectively, you have 2x square in the numerator, 2x square in the denominator. Hence the limit is equal to 1. Hence f of 0 has to be defined as 1 for this limit to be defined. Thank you.